Hello, let's discuss problem number 12, a very, very interesting spectra. Why interesting? Because if you see the mass spectrum of this unknown compound, he forget to give you the molecular formula of the compound. So it means we have to find out, first of all, the molecular formula of this unknown compound by applying carbon rule of 13. There is a rule which is known as carbon rule of 13. With the help of carbon rule of 13, we can easily find out the molecular formula of a compound with the help of mass spectrum. So if you see the mass spectrum, the molecular ion peak is appearing in the range of 156. So what you have to do, simply divide the molecular ion peak with the 13 carbon plus hydrogen 13. So divide with 13. If you divide with 13, so 13 times 1, you will get 13. 5 times 5 minus 3, 5, 3, 2, 6. So 13 times 2, you will get 26. This is N, means quotient. So the formula is CnHn plus R. This is the formula. With the help of this formula, we can easily find out how many carbon and how many hydrogen will be present in this compound. So this is N is 12. R is reminder in this formula. Reminder is 0 because everything is cancelled out. So let's put the values. So C become 12. H become 12. 12 plus 0 become 12. So this is the molecular formula of this unknown compound having only carbon and hydrogen. 12 times 12, 144 plus 12, 156. But if you see the mass spectrum of this unknown compound, he has provided a clear information that this unknown compound contains halogen. The halogen could be fluorine, chlorine, bromine, or iodine. It cannot be chlorine or bromine. Why? The reason is that in case of chlorine and bromine, we will get a M plus 2 peak. Chlorine plus bromine, in case of chlorine and bromine, we will get M plus 2 peak. While in this spectrum, we are not getting M plus 2 peak. It means the possibility of chlorine and bromine are ruled out. So now, might be the iodine is present. If you see the iodine atomic mass is 127. If 127, if you are getting a signal at 127, this is a clear indication that this unknown compound contains iodine. So you are getting a signal, you are getting a fragment at 127. So this is a confirmation that this unknown compound contains iodine and its molecular mass is 127. Means now total molecular weight is 156, while the mass of this iodine is 127. So 127 to 156 means 29. If we add 29, it will become 156. Means it's a unknown compound. Molecular formula of this unknown compound contain iodine, first of all. Iodine is confirmed 127. So molecular ion peak is 156, means 29. So 29 would be carbon and hydrogen. So how many carbon? 2 carbon, 24, and 5 hydrogen, 29. So this is the molecular formula of this unknown compound, and its molecular ion peak will be 156. Like iodine, 127, hydrogen 5, 127 plus 5, 132, 132 plus 24, you will get the answer 156. So this is the molecular formula of this unknown compound. So with the help of carbon rule of 13, we first of all identify how many carbon and hydrogen are present. Then simply, as the spectrum is showing halogen, chlorine, bromine possibility ruled out, iodine is present. So simply subtract the mass of iodine, you will get C2H5. Its molecular mass is 29. So 29 plus 127, 156. So it means this unknown compound molecular formula is C2H5I. So our first task is now to find out degree of unsaturation. If you find out degree of unsaturation using the same formula, 2C plus 2 plus N minus H minus X divided by 2 minus X divided by 2. So simply 2 remain as it is. How many carbon? 2 carbon plus 2, nitrogen 0, hydrogen 5, halogen 1 divided by 2. Halogen 1, iodine. Iodine is a halogen. Okay, so 2 plus 2, 4, 4 plus 2, 6. 6 minus 6 divided by 2, you will get 0. Means this unknown compound cannot contain any type of unsaturation. There is no double bond in this compound. No ring, no pi bond is present in this unknown. If you see the mass spectrum of this unknown compound, mass spectrum is clear. you are getting only sp3ch stretch over here. Nothing important information from the IR spectrum of this unknown compound. Okay, now let's move forward. If we move forward, if you see the proton coupled in, now he didn't show us the depth spectra, he has shown us proton coupled spectrum of this unknown compound. So if you see the proton coupled spectrum of this unknown compound, the proton coupled spectra give you a signal of CH2 and CH3, triplet and quartet. So CH2, one add, triplet, and this is quartet. I mean, one CH2 and one CH3 is present. While in proton decoupled, because we remove the hydrogen, so it becomes singlet, it becomes singlet. There is a no quaternary carbon over here, means no carbonyl group. Degree of unsaturation is 0, so the possibility of carbonyl group is even not possible. So one CH2, one CH3 is present. Okay, now let's move towards the proton NMR spectrum of this unknown compound. If you see the proton NMR spectrum of this unknown compound, first of all, the molecular formula of this compound was C2H5I, means this unknown compound contains 5 hydrogen. Okay, if this signal is of 2 hydrogen, this signal would be of 3 hydrogen. So this is a 1, 2, 3. This is a 3 hydrogen triplet, and this is a 1, 2, 3, 4. This is a 2 hydrogen quartet. This is the signal. So how to draw 3 hydrogen triplet? CH3, CH2. How to draw 2 hydrogen quartet? How to draw 3 hydrogen triplet? This is a 3 hydrogen triplet. How to draw 2 hydrogen quartet? This is a 2 hydrogen quartet. Remember, whenever you are going to draw 3 hydrogen triplet and 2 hydrogen quartet, the signal is, the fragment is always CH3, CH2. Ethyl is present. This is a hint, beautiful hint. Whenever you are going to see 3 proton triplet and 2 proton quartet, the possibility, the 100% possibility of ethyl group. It means this unknown compound contains ethyl group simply. So CH3, CH2, molecular formula is satisfied. This iodine left, so put iodine over here. So this is the structure of this unknown compound. Ethyl iodide is the name of this compound. So this CH2 is this one. Because it is close to halogen, so it is ppm is high. This one is over this. This is the proton and the mass spectrum of this compound. The 2 proton quartet appear in the range of 3.2 ppm, 3 proton triplet 1.9 ppm. And if you see the mass spectrum, if you see the carbon 13 NMR of this compound, simply this CH2 is this one, and this CH3 is this one. So you have to draw structure again, you have to write the value simply. And you can easily draw the mass fragment of this compound. If you remove ethyl from here, this fragment, you will get this signal and the range of, like if you see the mass spectrum of this unknown compound. So if you see the mass spectrum of this unknown compound, CH3, CH2, iodine. So if you remove this fragment from here, you will get a signal at 127. 127 is iodine. And how to get 29 signal? If instead of removing this arrow this side, if you remove this one over here, you will get this signal ethyl. This is the mass fragment of this unknown compound. I hope you have enjoyed this discussion. See you in the next session. Wish you best of luck. Bye-bye.